Is the screen visible?
Yes, sir.
Okay. So, in the last class, we have discussed the idea of integration and the consequent proofs and stuff. Now, today we want to start something a little different from what I have been doing till date. Today, we are going to start our discussion on game theory. Now, just one thing that I want all of you to just know beforehand, before we get into any details. Game theory as a topic is covered both in micro and in Mathico. Okay. So, as far as our discussions in Mathico would be concerned, we would be more interested in understanding how to solve some particular things in depth. Okay, we are not going to go into very details of each and everything, but we are going to understand different scenarios and the computational difficulties that might come up and how do we resolve them. That's the essential idea. So, so for all of you, let me just start with a basic idea of what we are going to talk about. Suppose you can think of it in this way that let's consider the telecom industry as of now. Okay, who are the, I would say, the most dominant companies in the telecom industry in India?
Geo.
And someone else,
Airtel.
Airtel.
Airtel. So there are two or three, right? Agar if we just calculate. So let's say we consider two for the timing. Geo and Airtel. Suppose I'm not writing anything, just hear me out. Both the companies are trying to devise some strategies to acquire as many consumers as possible. And when they acquire their consumers, that that it is an indicator of how much revenue will they earn, right? So if you take Geo for instance in the beginning, how much of revenue they will earn or how much profit they will earn not only depends upon their strategy, it also depends upon their competitor strategy, right? If the competitor strategy is better than theirs, they would earn a lesser profit. If they are better off, then they would earn a higher profit. So, whenever in such a competitive scenario, or whenever when we are having these kind of clash kind of a situations, your profit or your payoff, as we will say in game theory, depends not only on what you choose to do, but also on what others choose to do. Okay. So in micro, what I have been teaching you till now, it's something like if you think of the demand curve. Demand curve is basically a relation between the quantity and its own price. But it might be possible something like if you take an example of tea and coffee, you might find in many books that if the prices of tea fall, then not only will the demand of tea increase, but the demand for coffee will fall, right? So these are known as cross price effects. So that means whenever we are trying to understand the payoff, it is not only what our actions will be taken into account, it is also the competitor's action that we are going to take into account. Okay. So this is the first place in which we are going to differ in game theory. So there are two things over here. The people who are actually competing or are actually fighting in real world is what we will be calling as players. Okay. Next, each of these players will have their own set of strategies that they have devised and they will play accordingly. Okay, it's something like saying that they have a pre-planned list. These are the five things that I can do, and depending on the situation, they will decide upon which to do under what circumstances. So these are known as the strategies of players. Okay. And on implementing the strategies, not only theirs, but what others have done, that collectively taken together is what will determine how much profit or how much payoff will that particular player get out of this thing. Okay. And now what we are trying to understand is in the game theory part that what should be the optimal strategies that these two competing players should operate on to get the maximum possible payoff. Okay. Could you all follow the setup that I'm talking about? If you all can just reply with a yes or a no. Is the scenario clear that we are talking about? So now it is not only my actions determining my payoff or my utility or my profit, it is the action of others that will be equally taking part in deciding what my ultimate payoff comes out to be. Okay. Any questions from anyone over here? All right. So let us start with a brief introduction of the entire thing that I mentioned. Point number one. Let me first write down the basic things and then we'll begin with the computation. Point number one. A game consists of three parts or three components, so to say. Number one is the players. Number one is their strategy. And number three is the payoffs. Okay. Players are essentially competitors in real world. Strategy is the response by a player to any given situation. And finally, payoff is the final return or outcome of the game. Okay. This payoff can be either the utility, it can be profit, it can be anything depending upon the type of scenario that we're talking about. But whatever it is the ultimate outcome. That's the thing. For anyone who might have studied game theory earlier, might be having some notations in mind, but let me just put out what notations I would be using for the timing. Okay. So we will be starting with a two-player game. Player one, which in short I will be writing as P1, and player two, I would be writing as P2. Now, one question that I would want to ask all of you, that is it necessary that for any player there would be only one strategy? What do you think? Strategies can be one or many?
Many.
Many, right? Others?
Many.
Many. Because depending upon the situation, how they would react would determine their strategy, right? So obviously, it's expected that we would have different kinds of strategies to respond to different kind of situations. So for the timing, let us say that both the players have many strategies. Okay, something like that. And let capital S1 denote the set of strategies of player 1. And S2 denote the set of strategies of player 2. Okay. And let small s1 belonging to capital S1 be a particular strategy chosen by player 1 in a particular situation. And similarly, define a small s2 belonging to capital S2. Okay. So any particular strategy from the strategy set, I will be denoting by small letters, and the strategy set as a whole, I will be denoting it in the form of capital letters. Now, as I mentioned in the very beginning, that the payoff of one particular player depends not only on what his strategy is, it also depends upon the strategy taken by the other player, right? Therefore, let pi1, which is a function of not only small s1, his strategy, but also the strategy taken by the other player, is the payoff of player 1 for the strategy profile small s1, small s2. And similarly, pi2 of s1, s2 is the, just add one word which I missed, it's the payoff function, is the payoff function of player 2 for the strategy profile s1, s2. Okay. So now the question that we want to determine is how to obtain the optimal strategies of both the players so that they get the highest possible payoff from the game. I'd request all of you to reply with a yes or a no regarding the if you understand the structure of what I am talking about. It's new, it's different. So if you have any questions, maybe we can resolve that first before proceeding. Anyone? Any questions? Hina, are you saying something?
No, sir.
Okay. Others?
Sir,
Yes, Anisha?
sir, can you please elaborate the capital S1 and S2 part means the in type of function type like
It's a
S1 is
set.
equal to
It's a set.
yeah sir.
Set. It's not a function, it's a set. A particular player can have a range of strategies, right? Correct. For example, if I just go back to the one that we started with, the Jio versus Airtel. Okay. Suppose the strategy is to decide on whether to increase the marketing budget or whether to decrease the marketing budget. Right. So these are the two strategies that the company can opt for to get more consumers. So in which situation would they see? If they see their profits are increasing, then they can opt for a decreasing marketing budget strategy. And if they see their profits decreasing, then they would go for an increasing marketing strategy. Right. So depending upon the kind of scenario that they're facing, the company or the firm would decide upon which strategy to actually ultimately implement from the set of strategies that it can choose from. Okay.
Okay sir.
And sir, S1 and S2 are strategies, right?
Which S1, S2?
Small.
There are small. Small ones are strategies and capital ones are the set. Okay,
Okay.
so what I have basically done, I've just borrowed from your set theory notation. You must have seen in some maths books written, let small a be an element from the set capital A. That's the notation that I've borrowed.
Yes,
So,
sir.
so under capital S1, there could be any number of small s strategies from S1 to Sn.
Correct.
Okay, sir.
Absolutely. So if you all want, I can write that. I felt that it might confuse you also. I didn't write it. So it is something like, maybe if I just write very general, like you find some in some of your maths books. Capital S1 is something like this. Suppose it has M strategies and capital S2, let's say, has N strategies. Okay. You can take it in a generic format. And it's not really compulsory in a general scenario that the number of strategies that the players have need to be same, right? It could be different, it could be same, and like any kind of combination you can think of. Okay. Anything else? All right. So if you could understand the notations, then we can proceed with the next parts. Uh, so at least for now, at least for the time that we are doing game theory, our focus would be on understanding two player, two strategy games. This is what we have in our syllabus, so we'll stick to that only. And in your coming semesters, we will be elaborating more. Okay. So typically, your strategy set S1 will consist of only two elements, S11 and S12. And your strategy set capital S2 would be consisting of two elements, S21 and S22. Okay. Now tell me something. It might be possible that in a particular scenario, player 1 chooses to play his first strategy, player 2 chooses to play his first strategy. Correct? In that way, what would be the payoff of player 1? It would be a function of S11 and S21, and player 2 would be pi 2 of S11 and S21. Can any of you now tell me in this way what are the total number of strategy combinations in which the two players can operate? How many possible scenarios can happen?
So 4.
How do you get to that, Harshita?
So player 1 can play first or second strategy, and same goes for player 2.
Yeah. So 2 into 2, right? The permutation thing that you are doing.
Yes, sir.
Correct. So there can be 4 scenarios. Let us just write it for once since we are beginning. The second case can be, let's say player 1 continues to play his first strategy, but player 2 now goes to his second strategy. Similarly, the third case would be player 1 now plays the second strategy, player 2 plays the first strategy. And the fourth case is both the players play the second strategy. Can all of you understand one thing, that in each of the 4 cases, the payoff of player 1 will differ, can differ, and similarly for player 2, right? Can you all please confirm with a yes or a no if you understood this? In
Yes.
Sir.
Yes, sir.
Yeah. So in all the 4 cases, the payoffs of both the players can be different. So that is what I meant when I said that your payoff does not only depend on your strategy, it depends on the other strategy, the strategy implemented by the other player as well. Okay.
So,
Yes.
so in case 3 and 4, you have written as 2 and 1. But in the main first equation, there is no 2 or 1. There is 1, 1, 1, 2.
Uh, main
In pi,
equation mean
in pi 1, there is S1, S12, and S11, S12. But in
you're talking of this. You're talking of
yes,
this.
yes, yes, yes.
Okay. Let me rectify and let me just tell
Yeah,
you one
because
thing. I
it's
think
quite
you're.
confusing.
Acha chalo. Let me just change the notation then. S1 is, let's say, AB, and S2 is, let's say, CD. Okay. So in that means this is A and this is C, right? Correct. So this
Right.
is A, C, this is A, this is C. So this is your A, this is your D, this is your B, this is your C, this is your B, this is your D. Okay.
Okay.
Now tell me, Hina, what's the question?
No, there was no question. I just got confused because of the notation.
Okay. I got it. Actually, like since we were writing it in general, so I chose this kind of notation. So for 2 by 2, you can write as ABCD. That's not a problem. Okay. So that means in the first case, it's in this way. From the second case, can anyone tell me what pi 1 depends upon for the second case?
A and D.
A and D. And similarly, pi 2 depends upon A and D. For the third,
BC.
BC. And the fourth one will therefore be pi 1 is a function of B and D, and pi 2 is a function of B and D. Okay. Now this entire structure we will be writing in the form of a payoff matrix. Let me show you how we write it, and then we go into an example. Okay. So let's say I write the strategies of player one row wise and the strategy of player two column wise. So that means I'm taking player one as my row player and player two as my column player. This is very standard. You can switch it also. That will not matter. So just take note of this as well. Player one is my row player and player two is my column player. Now, what are we going to fill into these boxes? Take a look at the first box. We want to, sorry, just before that, the first box basically tells us that player one has decided to choose strategy A and player two has decided to choose strategy C. Okay. So now, if this is the case, what is player one's payoff? It is pi 1, which is a function of a comma c, and pi 2, which is a function of a comma c. Right? So it is just like the coordinates that you write, the row coordinate first and the column coordinate second. So you will just fill it in with the values. Similarly, now comes this box. Can anyone tell me what this box means? How do we understand this?
So
So
player,
two.
player one chooses strategy A and player two chooses strategy D.
Correct. Therefore, the first entry would be the payoff of player 1, which is now depending upon A and D, comma, the second entry is player 2, which is A and D. Okay, it's just like the coordinate system that you write. So just put a bracket over here. That will make it clear. And similarly, you all can fill up the other entries as well. So this would be player 1 choosing B, player 2 choosing C. So this would be pi 1 of B comma C comma pi 2 of B comma C. And similarly, the last one, pi 1 of A comma D comma pi 2 of A comma D. Okay. All right. Now let me take an example over here. Some common games. Sorry. Have any of you heard of this before?
Yes, sir.
Yes, sir.
Can anyone recall what scenario was there in this?
Sir, in the battle of sexes, there was an example of a husband and wife, and wife wants to go out for a dinner, and the husband wants to watch a football match, and then there is a payoff matrix, and the result came out.
Okay. So yes, correct. But just one thing to add on over here. So there are two players. Let me just write it out in total. Two players. Player one is the husband. Let me in short write down as H. And player two is the wife. There are two options for both. Two options. By options, I mean two strategies that they can take. So that means their strategy sets are the same. Capital S1 equals to capital S2. It is either go for dinner or watch football match. Okay. So H prefers, and they want to do it together. H preferred football and wife preferred dinner. So the question is, and both want to spend time together. So the question is, which one should they choose? So let us draw the payoff matrix now. So over here, what is their payoff? Is the utility, right? That both the players get from this game. So if we can just draw the payoff matrix, it would look something like this. So let's say I take husband over here, wife over here. The two strategies are dinner and football, dinner and football. Okay. If both of them choose to do the opposite thing, no one would be happy. So let us say their utility is 0 and 0 in these two cases. Okay, because both of them want to spend time together. So if they choose the opposite thing, then none of them get any utility. So that is 0 and 0. Now comes the first entry, dinner and dinner. Since in this case, both of them would be together, they get the satisfaction of staying together. But since it was the wife's better alternative, so wife would get a higher utility than husband. So let us say it is 1, 2. 1 is the utility of the wife and 2 is the utility, sorry, 1 is the utility of the husband, 2 is the utility of the wife. And similarly for the bottom box, it's football and football. So both of them are staying together. So the togetherness utility is there, but the husband prefers that. So it will be 2, 1. Is the formulation of the game clear to all of you? Any questions on this? All right. So now the question is, how do we determine what should be the optimal strategy? What strategy should the husband choose and what strategy should the wife choose? That's the thing that we want to understand. Okay. So since many of you have heard about this battle of sexes, can anybody recall how we actually solved for this?
So we look for the best response. So if husband chooses dinner, then for wife it will be best response to go for dinner. as she will get a more payoff of 2 than 0. And if
Okay.
husband chooses F, then
Is there any particular name, Ria, for this method? Or
uh, so I'm not recalling the name actually.
okay, not a problem. For people who are actually aware of this game, can anyone recall the name of the method that Ria just mentioned?
So elimination of best response function, something like that.
The definition would be that surely.
Nash equilibrium.
Indeed, that it is. That's something that encompasses your entire eco-honors thing, right?
So,
Sir, it's pure strategy game.
Uh, it is pure strategy, Harshita. Let's not get into that now. Let's not get into the distinction of strategies as of now. That's not what I really intend to do. Okay. For others, let me just share with you one simple way to understand this without much of technicality. Take it in this way: if the wife chose to go for dinner, then what should the husband do? If the husband chooses dinner, he gets a utility of 1, and if he chooses football, he gets a utility of 0. So, as a rational individual, he should choose dinner, correct? Others, could you follow this part?
Yes, sir.
So, just for your reference, just underline the 1. I'll tell you how it helps. This is just my trick of solving it faster. Now, if when you have understood what the husband would do, now take that strategy and look the other way around. If the husband chose to go for dinner, then what would the wife do? If the wife chose to go for dinner, she would get a utility of 2, and if she chose to go for football, she would get a utility of 0. That means uh, logically, she should choose to go for dinner. Okay, 1 and 2. Repeat this for the other strategies as well. Fix the second strategy now for wife. Suppose if wife wants to go for football, then if the husband chooses dinner, utility is 0. If she chooses football, utility is 2. So optimally, he should choose football, right? And now go the other way around. Husband choosing to go for football, then what should the wife do? If she chooses dinner, she gets a utility of 0. If she chooses football, she gets a utility of 1. So since football is higher, this is what she chooses to do. Right. So those boxes in which you have got 2 underlines are the one which is giving you the optimal in both the cases. Right. That means what I want to say, just now look at only these 2 boxes. Ignore the other. If the husband chooses to go for dinner, optimal response of wife would be, or the optimal strategy of wife would be to choose dinner. If the husband chooses to go for football, the optimal strategy of wife would be to go for football. That means the optimal strategy is either DD or FF. Correct. This is what the optimal should look like. I'd request all of you over here to reply with a yes or a no if you understood how we got to this,
Yes, sir.
the idea. Others?
Yes,
yes,
sir.
sir.
Yes,
Yes,
sir.
sir.
Okay.
Yes.
So that means you are basically trying to figure out those strategy combinations that will basically give you the highest possible payoff. And note one thing, it cannot be a overall highest, because if you think from so for your answer is either DD or FF. If you think from the husband's perspective, it should only be FF. And if you think from the wife's perspective, it should only be DD. Right? But it is not the individuals that matter, it's a collective thing that matters. It's a scenario based response. So you can't have an overall thing. Or my point being that you will not necessarily have one answer that this is the best and this is always what should happen. You can have multiple answers, and it is strategy dependent. So, like in this case, you have got more than one set of optimals. What does it mean? If husband chooses D, the optimal of wife would be to choose D, and the other way around. If wife chooses D, husband's optimal is to choose D. And similarly for the second player. All right. So that means these are the optimal strategy profiles. Of the two players. And note one thing, in game theory, multiple optimals can be obtained. And even no optimals can be obtained.
So,
Yes.
when the no optimals can be obtained, that kind of situation is called as an indeterminate solution, something like that.
Um, it's not really indeterminate, Hina. Like I don't recall it reading in any of the books that I have come across till date. Maybe it's there in some other, but it's not really indeterminate.
So,
We
what
just
it is
simply
called?
we simply say that the game is not solvable.
Okay.
Okay. So, like, there can be various ways of solving a game. So, one standard thing that we usually check is that if it's not solvable in this way, whether we can employ some other methods or not to solve it. Okay. But simply saying that the game is not solvable is something like saying that no matter which method you employ, you can't find a solution to it. Okay. You cannot find optimal in that sense. All right. That is what it simply means. Let me just give you an example of a no optimal case. Or rather, I would want all of you to just check whether this game has any optimal or not. Let me just write the game for all of you and maybe we can discuss the answer the next day.
So,
Yes,
so you are teaching this in maths class, right?
yes.
Yeah, because it's there in the micro also. So I
Yeah,
went.
just what I mentioned in the very beginning, Ina. Game theory is a topic that is taught in both. It's a part of math eco as well as micro because the concept is coming from micro and how you solve it is a math eco issue. So it's both mixed together.
Okay.
Okay. So let's say I take it in very general A, B, and C, D without giving any. The question is to check for optimal for this game. Okay. Do give this question one try and we'll discuss this answer on the next day. Okay. Try to find the optimal, and if there exists, what is it? And if not, then you will just report that we cannot find the optimal. That's it. So that's it for today's class, everyone. I'm stopping the screen share. Any other questions from anyone regarding anything?
Sir, you haven't told the name of strategies for the Battle of Sexes.
Anisha, the strategies are football and dinner. Those are the two strategies.
No, sir, also the method through which it is solved.
Okay, that I will discuss the next day. That's why I haven't. No, actually, I think it was Ria, right, who mentioned about Nash equilibrium. The method is Nash equilibrium, but I'm yet to explain how we do that. Okay,
Okay, sir.
that's something we'll discuss in the next day. The details of like how to compute the Nash equilibrium and why is it that it makes sense to compute Nash equilibrium. Both are important. Anything else? Okay. So looks like there's no other questions. So thank you everyone. That's it for today's class. Y'all can disconnect. We meet next week.
Thank you, sir.
Sir,
Thank you, sir.